water groundwater interaction? To answer this, streams often inspire us, but most of us doesn't know it interact with adjacent aquifers, which creates a complex path in the hydrological cycle. Here is an animation which explains the different process in the hydrological cycle. In recent decades, the surface water and groundwater interaction has received a lot of attention due to increase in water demand. In fact, there exists a relationship wherein the groundwater discharges to the stream, which is called as a gaining stream, and the surface water seeps into the ground, which is called as a losing stream. However, this relationship varies depending upon the different climatic and geological conditions. So now, why hydrological models? Hydrological models are the computer models which are used to quantify the water resources. Many watershed models have been developed which specializes at analyzing a portion of watershed process. It can be either modeling the surface water processes or groundwater processes, or linking both the surface water and the groundwater process. Why SWAT and what are the gaps in the SWAT model? SWAT stands for Soil and Water Assessment Tool. In SWAT, the watersheds are divided into sub-watersheds, and sub-watersheds are further divided into Hydrological Response Unit, which is known as HRU. It is the smallest modeling unit with unique parameters. Thereby, the watershed process like surface runoff and infiltration is simulated by lumping the processes in a HRU scale. Thus, the model lacks in simulating the dynamics and distribution of the groundwater and the recharge rates in the watersheds. Due to the major limitation in the SWAT, often it is integrated numerical or analytical model. So now, what are the different ways of modeling the groundwater? There are two different methods. One is numerical and analytical method. However, both the models either use partial differential equations or analytical functions to solve the groundwater flow problem. MODFLOW is the most widely used integrated model in which both the models use a different set of spatial discretization. Often, a translation system is required to exchange the input and output back and forth between the models. This in turn results in increase in computational time, loss of accuracy, and often the flexibility over the model domain is difficult. Owing to all these problems, the research questions are formulated. Is it possible to integrate both the models using same set of spatial discretization? Whether the boundary conditions can be flexible or easier? Can the model results be represented as a continuous function? Whether the model accuracy and the computational time can be improved. Research objective is formulated to develop an analytical element based groundwater model to couple with the SWAT for understanding the surface water and the groundwater interactions in a reasonable way. Here, this is a schematic representation of the exchange of variables between the SWAT and AEM integration. So the blue ones are the surface water process simulated by the SWAT model, and the yellow ones are the groundwater process simulated by the AEM model. The major outcome of the research is the integrated model will be a comprehensive tool to the research scientist or engineer to assess the water resources of the basin efficient, and also help the policy makers to inform the decisions on priority to ensure the water availability of the basin for the future conditions. Thank you.